Hi there. Welcome to another episode of eCHO live stream. This is episode 184, I believe. And yeah, it's a nice day. The weather is good. Yeah, so today we're going to be talking about like securing Kubernetes nodes with Cilium Host Firewall. So just to keep us up to speed with everything that's been happening in the community so far, if you don't know, Echo News is a bi-monthly newsletter that comes from Bill and basically keeps you updated with everything that happens in the eBPF community. So you can always subscribe to this newsletter on LinkedIn or like via the website, so where you fill in like your email address and you get this delivered to you. So yeah, if you want to keep up with what happens and with the eBPF and Cilium community, you should definitely be subscribed to the Echo newsletter. All right. So, what's new these days? So the goal, one of the interesting things I think I found from like this from this newsletter is actually some of like the newer blogs, the new projects that have been coming on. But you also have like some updates related to like isovalent. And there's also if we actually want to look at this, basically, it's basically a blog post that's talking about like kube proxy replacement with Cilium. So if you one that's one of the things that Cilium does like exceptionally well. Cilium replaces kube proxy. Right, so we've got some interesting blogs out here. We've got some, I don't think there are no videos. We've got some upcoming events. Some of them, I think they've passed. Some of them are are coming in the next couple of days. So, oh, and then we have very importantly, we actually have CiliumCon in that's co-located alongside with KubeCon in Atlanta. So, yeah, if you're gonna be attending CiliumCon and KubeCon, you should definitely say hi. There's also a sitcom BF workshop somewhere in September. Yeah, and yeah, that's I think pretty much all of like the that's pretty much a good summary of the newsletter. All right, so today we're going to be talking about like Cilium. Back to the business of the day, we're going to be talking about Cilium Host Firewall. This is actually I actually found this topic quite interesting. So if you actually want to follow along, so we have like a sort of like a general overview of a very not deeply technical general overview of what Cilium Host Firewall is. If you go to like the Cilium.io and go to use cases, you would see a section that talks about like Cilium Host Firewall. And if you need some, if you want to go like very hands-on and like try it out, you can always reference like the documentation. All right, so what exactly is Cilium Host Firewall, and why does it even exist in the first place? So when you think of network policies, right? You've got this network policies that protect like how traffic flows like between like in your Kubernetes clusters, between like the pods in your Kubernetes clusters, right? But then in like a typical cluster, sometimes you have like host processes like on the actual Kubernetes nodes that still need to be protected, right? So you need to control how like the nodes are accessed and things like that, right? You might have like some host processes running that's not in the Kubernetes cluster, right? And you want them to and you want to be able to secure and protect like this processes. So how do you do this, right? This is sort of like where Cilium host firewall comes in, right? So we're all familiar with Kubernetes network policies, right? And then Cilium builds on that and extends Kubernetes network policies with some more advanced and more granular kind of rule sets, right? And then Host Firewall actually takes this a notch up and takes that same very declarative model we use to like write network policies for Kubernetes, right? And take that and apply the same concept to the host, right? So now we could simply take the same way we would write like a network policies for like ports, and then go ahead and do the same thing for like the host processes, right? And this is very amazing, like in my opinion, right? So think of, for example, if you have a cluster on EKS, for example, right? So you'll have like your security groups, and then in your security groups, you define like a couple of rules, like in your security group, on how like nodes like actually flow through, like how traffic flows through, like the nodes, right? With Cilium Host Firewall, you can essentially do like the same thing, right? And so think, for example, if you were running like in a bare metal cluster, for example. You see, this actually sort of like eliminates like the need for you to like have like very complicated like firewalls or kind of like situation being set up, right? You can easily just take the same way you would apply you write like a regular network policy the same way you would apply, and for like a network policies to your pod, and you also manage all of that in a everything related to like how access is coming into your cluster in a very centralized way, right? So that's some of the biggest advantages of Cilium Host Firewall, right? You have that consistent security model that scales both for your pods and the underlying host node processes, right? So that is quite interesting. So there are a couple of like there's a previous echo episode on this if you want to learn more. There's a talk there's a talk there's a KubeCon talk for this. I believe there's also another KubeCon talk from Jeff. If you search on YouTube, you would find it. That also talks about like Cilium Host Firewall. All right, so it's really time to like just get our hands dirty and see exactly how this works. So anatomically, when you look at like the Cilium Host Firewall, network policy, like it actually doesn't differ from every other Cilium network policy. It's pretty much the same thing, right? So the very big difference, the first difference is, so if this is sort of like new to you, so this Cilium has the concept of a Cilium network policy and a Cilium cluster-wide network policy, right? So you apply a Cilium network policy to like the pods, right? And then you apply cluster-wide network policies, like the name apply actually cluster-wide to the entire cluster, right? So pretty much pretty much the same thing here. The only difference now is, since we are applying this cluster-wide network policy to the underlying node processes, not not the pods in our cluster, we actually, only anatomical differences when you look at like the Kubernetes definition, right? The CRD for cluster-wide net for writing like host policies is not selector, right? So now instead of us maybe writing like policies that would apply to like a specific pod, right? We now use like the node selector instead, right? So we're applying these policies based on nodes, and pretty much every other thing, how you write a write a Cilium network policy pretty much stays the same. You have like your ingress, you have your egress, you can define ports, you can define entities and all of that. So pretty much stays the same. The major difference is now you're actually matching and selecting based on like the nodes, the label of the nodes, rather than like the port labels. All right. So that's pretty much like in a very brief summary, that's pretty much what Cilium Host Firewall is about. So a good way for you to get hands-on with Cilium, with these things like this, is there's a couple of labs, and if you go to the main iSurveillance website, there's a couple of labs. And you can like just choose the so you can check out for them. So there's labs on everything from like egress gateway to transparent encryption to traffic optimization and things like that. So just bear in mind that some of this do not apply to like some of these are like at the iSurveillance enterprise labs. But yeah, you pretty much just see the ones that apply to OSS. I believe you can find them here. Yep, on the Cilium website, yeah, you can find them. This is pretty much much of this apply to like the OSS Cilium. All right, so right, let's start. So I'm gonna just go through like the Cilium Host Firewall lab, and yeah, we're gonna get our hands dirty. All right. So basically, all right, all right. So now this is the lab, and we're gonna set up like a very basic kind cluster, right? So if we look at the content of this kind cluster, we basically have a kind cluster that has one control plane and two worker nodes. And we've essentially disabled like the default CNI networking plugin that comes with kind. And we've also turned up like a kube proxy mode, right? All right. So that's essentially like the kind conflict. So we're just gonna create like the clusters that have already been created, right? So if we actually look at this cluster right now, the cluster, you can see like the nodes on the cluster are actually mapped already, right? And the reason this is the case is because we don't have like a networking plugin like installed. That's we don't have a CNI installed in the in the cluster yet, right? Remember we turned up the CNI. We didn't use the CNI that comes with kind, right? So like if you're doing this on your laptop in your local environment, you obviously have to go through the process of like installing like the Cilium CLI and all of that, but that's pretty much set up in this lab environment. So the lab environment is a way for you to quickly try out like Cilium features and play around with this. All right, so Cilium CLI has been installed here, but if you're following like locally, you might have to like install like the Cilium CLI. All right, so the Cilium CLI basically helps like you install like Cilium into your environment. Like it also detects like what's the ideal configuration and things like that for you, and pretty much helps like bootstrap the whole process of installing Cilium in a quite like very straightforward and easy way. So if you look at the config when we're installing Cilium, we have a couple of things that are quite interesting. So first, we actually we have host firewall enabled as true. We also turned off kube proxy replacement, right, to be true, right? So this is a prerequisite for using the host firewall feature. You need to have like the kube proxy replacement feature turned on, right? Yeah, and we have this. All right. So we're gonna enable Obol. So if you've not heard about Obol, Obol is the component of Cilium that basically does like much of the observability part, right? So you can there's a CLI for Obol, but there's also a UI for Obol. You can basically with Obol you can essentially see what's happening in your in your cluster, right? So Obol sort of like Cilium brings all that visibility. Obol sort of like displays it and shows you and allows you to query that data and essentially understand what's going on in your cluster. All right. So we're just going to confirm that our Cilium installation has actually been installed. So we actually see like the Cilium is installed and everything is working. Everything looks well. So we are going to basically query like the Cilium config to be sure that the host firewall feature is turned on. And if we actually, so you could do Cilium config view, right? And in our case, we just simply doing this and then grepping for host firewall, right? So we're just searching for host firewall, but we can see that host firewall is turned on. All right. All right. So the way we are going to test that host firewall is the way we're going to test like the firewall rules on our hosts on the Kubernetes nodes actually work is, so what we're going to try and do is like typical with every Kubernetes clusters, right? Like securing your Kubernetes clusters, you want to like control SSH access to the nodes in your cluster, right? You don't want anyone to just come. You want to restrict like SSH access to the node in your clusters, right? And like pretty much the way you would do this you would do this, for example, if you're in a cloud, you would, for example, write like maybe like AWS, you have a security group role that basically prevents SSH access on like specific ports, the port SSH uses, right? So we're pretty much going to try and simulate like the same thing here, right? So there's going to be some slight difference between, because we're using kind, and kind, basically the nodes are not actual like nodes, but Docker containers. So some things are going to be like slightly different or a workaround, but the concept still stays like pretty much the same. All right. So there's the concept of identity in Cilium, and I'm not sure if this is the first time if you're hearing of this, right? Let's see. Basically, you've got like the crux of the gist is that Cilium has this concept of identities where like instead of using IP addresses, right, to like identify workloads, right, Cilium gets like uses the identities instead, right, which is generated from like the labels of these workloads, right. So in a case here, identity one actually refers to like the local host, refers to like the node itself, right, the local host and the right. So we basically we're going to use Hubble to observe like basically what's happening on the host network, essentially, right? In the host network namespace. Remember, like containers will live like in a separate network namespace, and you would have like the host in the and you have like the host network namespace separate from like the container network space. That's basically how containers work, right? And in our case, I mean, there are cases where you have a pod that uses like the host network namespace, and I believe like this cluster-wide policies will also, this Cilium Host Firewall policies will also apply to them, since they are in the host network namespace. And from a network point of view, you can see them as a host process. All right. So we're going to observe, we're in this terminal 2, we're just going to observe everything that's happening we're going to observe like basically to identity, we're going to observe in the host network, and then we're observing like for port 22. Port 22 is basically the port where the SSH uses, right? All right, so this is where like the workaround, because we're using the nodes in this case are Docker nodes and not actual nodes. So basically we are basically querying like listing like the containers and looping through this, and then basically for each of the nodes, right, we are basically opening like a TCP connection on port 20 on port 22, right? So we're gonna do this in terminal 1 and see what happens, right? We can actually see like the packets are being forwarded, so we can actually, in practice, we should be able to SSH into like each of the nodes, right? And I believe if we want to get creative with this, if there's SSH on this, we should be able, like using like the IP address of the container, we should be able to like actually SSH into each of the container. But we're just gonna stick with like using netcats to like open like a TCP connection on port 22, right, for each of the nodes. All right, so we're going to go back to terminal 2, and you can actually see like the packets are being forwarded, right? You can see like this on this terminal 2, we actually have Hubble here. We can see like the packets are being forwarded, right? So from world entity going to like the node. So If you've not heard about entities, basically entities in Cilium are sort of like, I like to think of them as a logical grouping of like of um, of sort of like network source and destinations, right? So if you think of like a grouping like world, for example, you can't pin like a specific IP address. So when you have if you have a cluster, for example, with a front-facing application, you can have anyone accessing this application, right? So you can't logically group all the IP address that's going to be. So it makes sense that all the external IP address are grouped into one entity, and you can call them world, right? So there's another entity called, I believe, cluster that refers to like the cluster internal IP addresses within the cluster internal network. So, all right, so that's sort of like weird, of course. But yeah, all right. So we can from Hubble now we can see we can actually packets are going to the we can see packets actually going to being forwarded into like the into the nodes. All right. So so what we want to achieve now is we want to basically prevent access external SSH access to our node, right? So excuse me. All right. So if you look at our cluster now, remember we had one control plane and two worker nodes, right? And if we list the endpoints on one of the one of the nodes, right, would see like this identity one, right, which actually which is reserved for like the local host, right? The actual node, like the network namespace of the node, right? All right. So we can use like this. Basically, this is previously what we did in the previous step. We can actually use this step. We can use this to like filter traffic that's in the host network namespace, right? All right. So we're gonna craft like a Cilium. We're gonna craft a network policy, and basically, essentially, what we want this network policy to do is to prevent SSH access to a specific node to using like TCP because SSH is TCP, right? As TCP and port 22, right? So we want to basically in the crux of this network policies, we want to say we want to prevent TCP connection on this specific port to this specific node, right? So we want to say we want to prevent TCP connection on port 22 to the nodes in our cluster. All right. And at the same time, we want the nodes in our clusters to still be able to access like the Kubernetes API, right? On the control plane. Okay, so how do we what's the first way what's the first way we approach this? So if you think of this, so the first thing we want to do is we want a policy that allows all other nodes in the cluster to be able to still access the control plane node because that's where the Kubernetes API lives on, right? We don't want like if our worker nodes can access like can communicate with the Kubernetes API in the control plane nodes, then the worker nodes become unavailable, right? And that's not the case. That's not what we want to happen, right? We want whatever network policy we decide to craft later, we still want our worker nodes to be able to effectively communicate with the KP API server on the control plane node. All right. So if we look at our node, we can see like our node has a label that is this label that essentially tells us that this is a control plane node, right? So we're gonna use this label to actually craft this network policy, right? So we're gonna write this network policy and use this label to make sure that this network policy is targeted at specifically our control plane node. All right. So we're just gonna take this network policy to the detour and on the control plane, So let's look at this network policy that allows basically the ingress to our API server. So the API server lives on port 6443, right? And basically this network policy here pretty much allows ingress to the node where the control plane is, and specifically on port 6443. All right. So this is pretty much like, if you look at this object, the network policy definition, it's pretty much like straightforward, right? We have like we're selecting on the nodes using the label, the control plane label, and we're basically saying like ingress. We want ingress and we want this port with the specific protocol. And that's like pretty much straightforward. All right, so let's apply this network policy. Now, the next thing we want to do is using like the principles of zero trust, right? We want to like explicitly like default deny like every network traffic and then write policies. Like this is actually a very, very good way to build like your policies. You start from like a default deny sort of like baseline, and then you explicitly allow only the things you need to allow. So like this follows actually the principles of zero trust. So this is a very, very good way. If you write in network policies, it's nice to like break them down like into sort of like a logical way like this. You have a separate policy that does like all the default deny, and then you can have individual policies separately for like the services you need to allow to communicate, right? It makes it like quite easy. In my experience, I found it makes it like quite easy to manage. I mean, essentially, you could take all of this and compress this into like one network policy object, and you would be fine. But it's usually like easier to write this way. All right. So default deny. So we're not gonna do with default deny, right? So default deny, we're gonna put this in here. So basically, this entity cluster, basically, there's a cluster. I'm going to say, let's see, Cilium entity cluster. Let's see, I actually want to see, we can actually see what this entity, yes, all right. So if we look at this cluster, so this cluster is a logical group of network endpoints inside the cluster, right? So this includes like all Cilium managed endpoints of the local cluster, managed endpoints in the local cluster, as well as the host remote node and init identities. This also includes remote nodes in the cluster mesh scenario, all right? So that's basically what this entity is. So we're saying basically every other node in the cluster, every other network endpoint in the cluster, we're saying like block this traffic from them, right? So when you don't specify any rule under this, like Cilium goes by default into like a default deny posture, right? So that's essentially what this is about. All right. So we're gonna go and apply this default deny policy, right? And now when we try to query like we can see like we can see like we have two Cilium network policies now in place. The network policy that allows that explicitly allows access to the API server, because we don't want, for any reason, if you think about this, if we did this the reverse, we had this default deny in place, right? First, before we applied the access to the control plane API, we would have lost access to this cluster, right? Because then if we applied the default deny network policy, we wouldn't be able to like query like the Kubernetes API to like send in like other policies, right? And that would have been a problem, right? So So it's usually we first whatever thing we're doing, we need to make sure that the kubeAPI server is accessible because it's the brain of the entire cluster. And then yeah, before we apply all right, so we're gonna go to our bowl now, and we're gonna observe network traffic from our identity 1 for port 2, right? All right, let's try and now SSH into our clusters and see what happens. Remember, we have a default deny policy in place, right? So if you see now, like this our connection to each of the nodes actually times out, right? Why does it times out? It's because we have a network policy in place that actually prevents like TCP access on port 22. That prevents entirely, like, apart from like access to the API server, you can't reach any of the nodes here, right? All right. So what do we want to do now? We basically want to create like a network policy that's gonna allow like SSH access to just the control plane node, right? And this is sort of like the concept of using like the control plane node as a bastion host, right? So essentially what this means is you don't want to be able to like just ask SSH access directly to like every other node in the cluster. You want SSH access to be able to only happen from a specific node like the control plane node, right? Right. So you want to prevent SSH access to all other nodes in the cluster except when it's coming from the control plane node, right? So this is the whole concept of using like the control plane node as a bastion host. All right. So we're gonna take this, go to the detour, control plane. Basically, what's this network policy saying essentially? This network policy is basically saying that, hey, like now for the control plane node, we want to allow SSH access now, right? Remember the default deny prevented like every other network traffic from coming in, and we can only access like the API server, right? So now on the control plane node, we want to be able to SSH into the control plane node. That's essentially what this network policy does, right? All right. So we're going to apply this network policy. And now if we try testing like the SSH connection again, you would see when we try to go, you see like connection to the second worker node field, right? Connection to the first worker node field, but only the connection to the control plane node, which we applied this policy for, actually works, right? So now we basically allowed SSH access to the control plane node, right? And then another thing is we want to be able to see if we can access if we're able to access the worker nodes, right? From the we want to see if we can access the worker nodes from the control plane nodes, right? So we're just gonna go. We're gonna like exec into like the control plane into in this case it's a Docker container, right? And then we're gonna try reaching all of the worker nodes. You can actually see that this actually works. But if we're outside the control plane node, right, from world, you can see like our network policy in place would not allow us to access the worker node. So we have to be in the control plane nodes to be able to access like the worker node. So you can think of like various applications how this could be very quite helpful, right? This can replace you having like firewalls in your cluster. and having complicated setup. You just have to do everything like the same way you would manage your network policies. You use like the same very declarative model to manage like access to your hosts. And yeah, and if you have like host processes, things that are running outside like the cluster, right? For some reason, the things you have like host processes running on the side, running outside the Kubernetes cluster, you can still use like our Cilium. You can still use our Cilium network policies, Cilium Host Firewall to be specific to actually secure this, right? So in this our case, we could see like we had we had like the SSH daemon that's obviously running outside like the Kubernetes cluster, right? And we can actually have rights network policies that actually prevent like access to like the Kubernetes nodes. So yeah, I really hope like this is quite informative. If you want to know more, there's a lot of like things I didn't cover here. There's, for example, like there's a policy audit mode where you can actually, because these are quite, you could lose access to, you could lose access to your nodes, right? With this, right? So you need, you can use the policy audit mode to sort of like try out this network policies first to be sure, so you don't lose access to your node, and then you can then basically disable the policy audit mode and actually have these network policies actually working now, right? So yeah, this is quite an interesting one. I did hope everyone had something to learn from this. We look forward to seeing you in another episode of eCHO. And yeah, thanks for coming in. The labs, if you're curious about the labs, they're on the i7 website. You can go to like the labs, and you will definitely find them. You're in the lab list, right? You definitely find them in the lab list, and you can go ahead. You can go through these tutorials, and like you get a badge for completing like those labs, and they're very 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 nice way to learn about Cilium. Thanks for coming in. See you in the next episode of eCHO. Bye.